So again, if I want to launch something so that the object has a horizontal velocity of 3 meters per second and an initial vertical velocity of 2 meters per second, what launch speed should I use and what launch angle should I use? Tomorrow's quiz is similar to this. I'm going to have like 4 different versions because I'm not going to be here, so the sub has to hand it out. They'll be color-coded. So you have to make a triangle. Remember we talked about that yesterday? Step 1, I think you can all agree that there's already a coordinate system implied here. So I don't think I have to worry about putting a coordinate system on this. I think the horizontal is one direction and the vertical is the other. Is that okay? So I'm going to make a triangle out of this. I have 2 choices, and I think the best choice is to do that. So let's break those up so I don't have the little number in the way. So I'm making this choice because that puts the angle that I'm looking for as the angle of focus. So I'm going to start with that. I'm going to label my sides. So I've got, this one's the opposite, this is the adjacent, and this is a hypotenuse. That all good? All right. So sine of my unknown angle is opposite. Well, I know what the opposite is. I might as well just write it in. So 2 over hypotenuse. The cosine of my unknown angle is adjacent, 3 over hypotenuse. And tangent of my unknown angle is opposite over adjacent. I have to stop at this point, check and make sure my calculator's not in radians and put it in degrees. And then I have to choose which direction to go. Do I have 2 sides or do I have a side and an angle? It appears that I have 2 sides. So because I have 2 sides, I'm going to find a ratio that is complete and use that ratio to figure out the angle. So this is the one that's complete. It's 0.6667. Go 4 decimal places if you're going to be writing out parts, because if you don't, you'll find that you will have a problem. You won't get the right answer. So try and go out as many decimal places as possible, because small changes here make for big changes in the angle. This ends up corresponding to what I think is 33.4 degrees. Is that right? 33.7 degrees? All right, so once I know that that's 33.7, and I did have some question about that, and let me just kind of write out something. I'm not sure I wrote this out yesterday. Technically, you're taking like the inverse tangent of both sides, and taking the sine of both sides of an equation or the inverse sine. I mean, you can do it, but you're trying to get the angle by itself. So if you're trying to kind of figure out what it's going to look like on your calculator, it should kind of look like this on your calculator. If you're using a TI, you can put 2 divided by 3 in the parentheses. Because it'll do all that. It'll do multiple things at once. And this is what's going to give you that 33.7. Now, once you have that, I told you that you should go further and figure out the hypotenuse by using trig as well. But remember, you don't have to. I mean, you have other methods. You could use the Pythagorean theorem and figure it out. And there's nothing wrong with that. It works. I'm giving you a second option so that you can check your work. So I'm going to use that second option. Give me just a second because I gave my calculator away. So I haven't used my phone. Not as good for me. So let's see, inverse tangent, and then I want to find the sine. I get 0.5547. So this equals 0.5547. And this one equals 0.8321. So I've had this question a couple times, but if I want to find h this way, I just pick one of those. I can pick either, but I'll just pick one. 2 over h equals 0.5547. So if I want h by itself, yesterday I said just multiply both sides by h. That's a fine way to do it, and it works. So That'll give you 2 equals 0.5547 times h. And now to get h by itself, divide. So 2 divided by 0.5547. 3.6. Now, this is what I'm looking for you to be able to do tomorrow. We all good? I mean, there's more that I want to be able to do, but this will be a start. Yes, sir?
When you got the 0.5547 for sine, how did you get that?
I found that the angle was 33.7. So over here, I did sine of 33.7 and the cosine of 33.7. Does that make sense?
Yeah.
All right. Yep.
Adding on to his question, for the two over the hypotenuse, would you have to multiply those? Because I know yesterday you had to multiply the denominator to get the answer.
No, I mean, this is just the algebra to do that. That's all I did. I mean, there's other algebra to get there, but I'm just trying to isolate h.
I see what you're saying. Okay.
Does that make sense?
Yeah.
Okay. Anything else? I'd like you to try something for me. It's kind of a little numbers game. So I'm going to put this over just up on the side here. And it'll take your calculator to do this. So I want you to take the 0.5547 and square it and add it to the 0.8321 and square it. And then add them together. Do you get one? Okay. I want you to see something. You may appreciate it. You may not appreciate it. We'll find out. Okay. The 2. This is the opposite side, right? And the 3 is the adjacent side, right? So follow me on this. 2 over h equals sine of 33.7, but that means that the opposite side equals h times sine of 33.7. I just put the O back in for opposite. Is that okay? 3 over h equals cosine of 33.7. So that means A, adjacent, equals hypotenuse times cosine of 33.7. Okay, so far? All right. Everybody's following okay. Opposite squared plus adjacent squared equals h sine 33.7 squared plus h cosine 33.7 squared. Right? You guys follow what I did? I just put O in. I put this in for O, and I put all of this in for A. That okay? No problems? Do you notice that I have an h squared in both terms? Do you guys see that okay? I'm going to factor it out. And that leaves me with, and I need you to see this, if I want to write this sine of 33.7 and then square it, you put the square sign next to the sin part, and then you write 33.7. This is how you write the square of the sine of 33.7. I know some of you know that, but not all of you. So you don't write this as sine 33.7 squared, because that says to square this number and then take the sign. Does everybody understand? So this is how it's written. And plus cosine squared 33.7. But you guys just showed yourselves, right, that if you take the sine of 33.7, which is 0.5547, and the cosine of 33.7, and square them and add them together, you get 1. Did you notice that? So that means all of this is just 1, right? Has to be. That means that we've proven the Pythagorean theorem, right? Do you think that's true just for 33.7 degrees? No, it's not. And so on your trig chart, I want you to have, or on your trig cheat sheet, I want you to have a little section that you call trig identities. And this is one of the trig identities I want you to know. Trig identities are ways to replace one trig function with another trig function. There's lots of them out there. Apparently, mathematicians have way too much time on their hands, so they've come up with all sorts of these. Okay? I want to show you one more, and then we're going to go back to regular content, okay? Your trig identities, I want you to know that one too. All right? So I want you to have these trig identities, have it on your trig cheat sheet, and also, did you notice today that although I let you write down anything you wanted on your trig cheat sheet, in some cases it was not enough to assist you in doing this job? What I would encourage you to do is fix your trig cheat sheet. If you were unable to do what I just asked, make it something that will help you. Add some words in there. Because I walked around and step 1, apply a coordinate system. Right? Define what is X and Y or north or south or something. Apply a coordinate system. What are you going to be referencing? Right? You want to create or identify a triangle? I mean, there's got to be one in there somewhere. Locate what your angle of focus is, and then label opposite, adjacent, and hypotenuse. Write out the trig functions. All right, we stop here, check our calculators, because we're about to fork this, right? You have to decide which direction to go now. We good? I'm gonna slide this out of the screen. So there's 2 potential ways to go. So there's the way where you have an angle and a side, and the way to go if you have 2 sides. All right? So let's do the angle side one first. So this will be step 5. Compute all 3 ratios from the angle. You should now have a pathway to find the missing sides. All right. Now, if you have side, side, you have to find the completed ratio, right? Because you're going to have 2 sides, so one of the ratios is going to be complete. Find the completed ratio and compute the inverse function. I'm going to put one more word in there to get the angle. Find the other 2 ratios using your newly found angle. That way you can find the missing side. Or O squared plus A squared equals H squared will find the missing side. You can either do these things or you can do that. Does that help? Okay, so now, while we're doing these, I want to show you one more. Because this one could show up today. It probably won't because we're on short schedule today. And I would be really surprised if anybody knows this one. Does anybody know this one? The angle sum and the angle difference formulas? One of you?
I don't know it that well.
Because there's like this one, and there's a similar one where this is a negative sign, and then there's ones for cosine and stuff like that. This one, I don't really care if you know this one. But here's what I want you to do, because you guys are smart people. I want you to replace the B with another A. Can you do that real quick? Now, I know I can, so I'm just going to erase all those B's and put A's there. And the first thing I'll notice is I can just add the ones on the right side together. Do you see that? So it's just going to be 2 times sine A cosine A. And the left side is sine of 2A. This one is called the double angle formula. And this one we're going to use actually within the next couple days, if not today. Sine. And this is what a theta looks like to me. I didn't say this earlier, but some of you are probably seeing like Greek letters for the first time or don't see them often. And one of the things we don't do since kindergarten is we don't really talk to you about, what these letters are supposed to look like. So do you remember having paper like this when you were in kindergarten? So like if I wanted to write an A, right, it's like that. So this is supposed to be a lowercase theta. So lowercase, because uppercase theta is like, it's like something like that. It's big, it's complicated. But lowercase theta should roll off the pen. So it's like a H, you know, where it goes all the way to the top. But, so it's that size when you write it compared to other letters. That's the way it should look. We'll use a lot of different Greek letters in here. And so usually whenever we have a Greek letter, I stop and I talk about the way it's gonna look like when I write it, because my handwriting is not particularly great, but you know, I think you should see it so you can recognize it. So that's kind of what it will look like when I write theta, all right? I use 2 different Greek letters for angles, and I use the traditional ones that are in this class. That's one of them. The other one is phi, which looks something like that. The O is a little bit bigger than the middle line, but then you just draw a line through it. So I use those 2 letters to describe angles all the time in here. So whenever there's some unknown angle, I'm going to use the letter theta for that, okay? It's pretty traditional for physics to do that. So I just want you to be kind of clued in. All right, so enough of that. That was just me trying to be nice. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, right? So opposite over hypotenuse divided by adjacent over hypotenuse. I know some of you are just not great with fractions. It's kind of coming to light as we do stuff like this. But this is 2 fractions and we're dividing them. Now, if you remember, do you remember like what you had to do in elementary school to divide 2 fractions? Do you remember the rule?
Keep, change, flip.
Keep, change, flip. Yep. So if it was written like this, what does keep mean?
Keep O over H.
Right?
And then change the sign and then flip.
Change the sign. That's right. And then flip the fraction. Aha.
That's right.
Yeah, well, I hope not. I mean, I feel bad enough for the people who peak in high school. You know,
No, elementary school was
if you peaked in elementary school and it's downhill from there, it's a long, long downhill slide.
It's been rough.
Notice the H's cancel out. You guys see that? And we get, and this should, I hope isn't a surprise, you get opposite over adjacent. But you know what that is, right? That's tangent. So I'm saying that because if you look at what we've written, this is sine theta over cosine theta. And obviously, because of keep, change, flip, that must be tangent theta. This actually shows up in this class quite a bit. So